This is Chapter 8 Summary Notes on Gases. This particular video is about the combined gas law. All right, and you can see on your screen the formula for the combined gas law. And within that combined gas law, you can see three of the other gas laws that we've already discussed. And we'll circle them as we take a look at them. All right, pressure and volume, that is Boyle's law. All right, and then you have Charles's law, which is volume over temperature. And then you also have Gay-Lussac's law, which is pressure over temperature. But all of these were derived from the ideal gas law. All right, so when we look at the combined gas law, we are only keeping the numbers of moles constant, and of course this R value, which is the universal gas law constant, will drop out. All right, and the gas law, the combined gas law, compares one set of conditions to another. The ideal gas law just describes one set of conditions. So we know that when we set one set of conditions equal to another, there's a constant that's involved with both sides of the equation. All right, so we can solve for one of the variables given 5 of the other terms. Okay, and sometimes those, it's just a matter of chugging and plugging. All right, so let's take a look at this first one. We'll assign our variables as we go. And I see we have a volume first, and we'll do that volume in blue. We have a volume of 675 mLs. All right, the first temperature is 35 degrees Celsius. And if you remember, we add our 273 to that right away. And that gives us 8308. All right, Kelvin. And then we have our pressure. All right, and the first pressure is 646 millimeters of mercury. Okay, and then when we take a look at the second set of conditions, we are looking for the volume. We are looking for the new volume in the same units, all right, which is good. We don't have to worry about trying to convert those. We're looking at a temperature of T2 is equal to 95 degrees Celsius plus 273. And I'll bring up the calculator for that. Negative 95 plus, not times, plus 273. And that gets us 178. Kelvin. All right, and then the second pressure is 802. All right, let's get a little more room on the screen here, and we will, whoa, that's not what I want to do. See if I can come over here and do that. There we go. All right, so we are solving for V2 out of what we have up here. Let me erase some of this other stuff. All right, we're looking for the second volume. All right, so we want to get T2 on the left-hand side, and that goes up to the numerator position, and the P2 will come down to the denominator position. So rewriting the formula, T2 will be over T1. P1 will be over P2. All right, and V1. All right, we're solving for that second volume. Now, fortunately, it's a little more difficult to predict what's going to happen because we're dealing with 5 different quantities here instead of just 3. And we only have 2 variables involved. In the other gas laws here, we have 3. It's a little harder to predict. Okay, but let's substitute the numbers in and see if we can do a little predicting. All right, so T2 is 178, so that's going to go on top. My T1 is 308, so that's going to go into the denominator position. All right, then let's bring in the pressure. P1 is 646. millimeters of mercury. And on the bottom we have 802. And then finally we have volume. The first volume is 675 mLs. Whoops, let's get the 5 in there. Okay. All right, so double check and make sure everything is in the right position. Double check my T2 needs to be 178, so that goes on top. So we can take a look and see if we can make some kind of prediction. All right, that number is less than 1. This number is also less than 1. This fraction here is also less than 1. So our volume should go down, yes? All right, let's see what happens. 178 times 646 times 6.75. All right, then I'm going to divide by, I'm going to use my parentheses, 308 times 802. All right, I get 3.14. All right, so 3.14 is my new volume. All right, so that makes sense because if this fraction is less than 1 and that fraction is less than 1, then 6.75 should go down. All right, so I can make a prediction to that extent. Okay, let me double check to make sure I have everything else lined up in this solution for you. All right, now let's get you to try this next one. All right, it has a volume of 0.180, a pressure, first temperature. Don't forget to change to Celsius, to Kelvin. You're looking for a new temperature, and you're given another volume and a pressure. All right, so pause the video, try your work, come back, check your solution. All right, on this problem, I hope you caught a couple of things that you needed to fix. One being the first volume is given in liters, but the second volume is given in mLs. So liters needed to be changed to mLs, or you could have changed mLs back to liters, just as long as the units were the same. All right, so I do have the same units for both of those. Did you remember to change your Celsius temperature to Kelvin? All right, I hope you did, and I had 302 Kelvin for that answer. All right, and then the atmospheres, there was no change in units for that. All right, notice what I did with the formula for the combined gas law. I flipped both sides. We saw how to do that in a previous video. It generates another constant, but it makes things easier when you have to solve for a term that's in the denominator. So you just flip your formulas, and that makes it very easy to clear the volume and the second pressure from the right-hand side, because you're multiplying both sides by the inverse of that. And you see the new formula over here to the right. All right, a little less manipulation going on there, and then substituting in the values. All right, and there's a lot of things that we don't need to even worry about on the calculator until we get to the end here. And I want to show you why. Because 80 into 90 mLs, I'm sorry, that should be 180. Okay, I knew something was wrong there. All right, so 90 into 180 is 2. Okay, so that's just a 2 in the denominator. And the atmospheres here should be 0.8. And 0.8 into 3.2 is 4. And then 2 into 4 goes twice. So 2 times 302 gets me 604. So anytime you can not use the calculator to help you find your answer, please go for it. All right. And then if I subtract 273 from that, I get 331 degrees Celsius, because that's what the problem asked me to do with the temperature. Okay. Would this have been easy to predict what happens? All right, I have a value here. The milliliters turns out to be less than 1. All right, but the atmospheres is greater than 1. So it's a little harder to predict what's going to happen to the temperatures. It's true that the atmospheres are way more than the fraction is for the volume. So maybe you can do some predicting there, but it's not as easy. Okay, and so that ends Charles's law. I mean the combined gas law. And again, all these are derived from the ideal gas law, and we'll see that in a little bit. All right, we're going to take a look at Avogadro's law next.